Hello, we are Group Redwood, and today we'll be discussing the inverse square law. The inverse square law is when something's intensity changes due to the inverse of the square law of the changing distance. Now let's try it. And since we are working with sound, we have to take into account that volume will be measured in decibels.
So if it sounds twice as loud in your ears, then the decibels are going up by 3. So that means if it sounds twice as low in your ears, then the decibels are going down by 3.
For this experiment, we're going to be using a meter, this time a meter paper. It's in centimeters because we're going to mark down 2 meters and 4 meters for our experiment. Another thing we're going to need is paper to mark down our 2 and 4 meters again, and our speaker. This time we're going to measure with our little paper and meter. We're going to measure from 2 meters to 4 meters very exactly, so maybe we can get like good results. The paper is hard to use, but I think it gives us a better way of measuring. We're also going to need an application called Decibel 10. It's really easy to download in Apple Store. It's for free, and that's going to help us measure the intensity. We're going to measure the intensity in decibels. For the sound, we're going to use white noise because if we use a song, the dynamics is going to go up and down, and we don't want that. We want something like that can give us some accurate results, so white noise was our choice. We're gonna measure the intensity from the speakers, 2 meters away from the speakers, and 4 meters away from the speakers. From the speakers, the intensity was 82 decibels. 2 meters away, it was 79 decibels, and 4 meters away, it was 74 decibels. Our results were mostly accurate. The last result was 1 decibel off, but mainly we did a good demonstration of the inverse square law, and we had a lot of fun.
The reason why inverse square law is important to the RA program is because without it, we won't have any scale in particular to address what we're mixing, to like scores in movies, to even recording in a room such as this one. It's very important. I cannot stress enough how important this is, because when you're, say you're a producer and you're making your music, even though that you're supposed to be producing the music, so okay, playing keys or anything from playing guitar, even though you record that in and you're not supposed to be worried about how loud it is, you still have to do some tweaking to level everything out. And the inverse square law is very important in that, because that's the pretty much the only way you can do so.